Alrighty, folks. So we'll pick up from how to find the present value. So, of course, the idea here is, you know how much money you want in the future, and we're actually working backwards to see, okay, how much money should we deposit today so that, after whatever the time period might be, we will have that amount of money that we are hoping to have in the future. So in this case, they had actually shared that formula with us when they shared the compound interest formula with us. So it's right over here. And this is the formula that you would use if you knew how much money you wanted in the future, but how much should you deposit today? So basically all they have done to the original compound interest formula is divided both sides by that parentheses part and brought it down to the denominator of a. So you end up with 1 plus r over n, and then the whole thing raised to the nt power. So that's basically what's literally happened over here, is they've taken this parentheses part and divided it in both sides of your equation. So p comes by itself on one side, and then a gets that whole big denominator. So that's basically the formula. Again, if we were doing this by hand and if we were going to calculate what the principal should be, if we knew the amount. But again, since we have been talking about built-in functions, there is also what we call the present value formula that your spreadsheet has, called the PV for present value, as you can imagine. So it's kind of works in the same way. You take your rate per period, so that would be your rate of interest divided by your compounding period. So is the interest being calculated, monthly, weekly, quarterly, that kind of thing. For the number of periods, that's of course going to be for how long are we depositing this money, and again, what your compounding period is. So n times t. Payment amount actually depends on, are we making regular payments or not? If you're not making regular payments, remember, this is the one where we just put a 0. And now in this case, the last argument is going to be your future value. So how much is that amount of money we desire in the future? So that's the A value. So as you will notice, this is very, very similar to our future value formula. The first 3 arguments are the same. When this is the future value formula, you put your principal here. Now that you are finding the present value, we of course put the future value as the last argument. So they literally just kind of switch places in both formulas. So let's go ahead and take a look at an example here. So they're talking about, that you will need 40,000 for your child's education. Did I let him in? I think I did. So they're talking about needing 40,000 for your child's education in 18 years time. So maybe, they were trying to open this account right when the child was born, and that's why they're going for 18 years here. They're saying this account will earn 4% compounded quarterly interest. So how much should we deposit today? So as you can see, our future amount is $40,000. They're telling us we're going to be doing this deposit for 18 years. Our rate of interest is 4%. And then, of course, we are compounding this quarterly. So remember, quarterly is 4 times a year. So again, following that, present value formula, let me try to squish that in here. So basically, you can see for the rate per period, you're going to take R divided by N. So that is going to be 0.04 our interest rate divided by how many times the interest is being calculated, 4 times a year, quarterly. So you can see that's where that 0.04 divided by 4 is coming from. Then for the number of periods, we do N times T. So again, your N is quarterly 4, and then we're doing this for 18 years. So 4 times 18 is where this is coming from. We're not making regular payments, so this argument stays 0, and then our future value is $40,000. So literally just throw all of that into the present value formula, and then it will tell you how much you should deposit today, so that 18 years later, we will have $40,000 in the bank account. And as you can see, that present value, once we do the calculation, comes out to be $19,000. $539.84. Now, if you were going to do this by using the formula, then this is what the formula would end up looking like. And let's see if we can make this guy slightly bigger. So in this case, you take your $40,000 and you're dividing it by, remember that whole parentheses part. So 1 plus R divided by N. So R divided by N would be the 1 plus, again, 0.04 divided by 4, and then you raise the whole thing to 4 times 18, and it will still give you the same dollar amount, $19,539.84. So again, we're going to try and do this both ways, but just using Google Sheets to help us do the calculation for us. So let's pick an example over here. And we're trying to find the present value. So let's see. How about number 12? So this is talking about how much would you deposit into an account now in order to have 6,000 in the account in 8 years. Assume the account is earning 6% APR compounded monthly. So in this case, our future value is $6,000. They're telling us we want this money in 8 years' time. Our interest that we are earning is 6%. So again, as a decimal. And then let's see, they're telling us it's compounded monthly. So again, we're going to shift this over to our spreadsheet. So let's come over here. Okay, Sabrina, no worries. I'm actually just going to open up a new spreadsheet here. And again, if you guys needed to see what I'm doing, I'll go ahead and share the link of this document with you guys. So just look through your Zoom chat. And you'll see the link for this. This is the same one we were using last class. It's the same one if you have the link saved, but if not, I just shared it through chat. Alrighty, so let's go ahead and enter these amounts in here. So our A value is $6,000. And again, I'm just going to format that. What did I do? Just going to format my 6,000 as a dollar. So just click on this little dollar symbol here. Our time is 8 years. Let's see, rate of interest is 6%. So I'm going to format that as a percentage by clicking on this. Then I'm going to type my 6% in. And we are compounding this monthly. So remember, this is 8 years and our compounding is in monthly. So now remember the formula, if you were just using the formula, that is A equals, sorry, not A, we're finding the present value. P equals, and then you take A and then divide that whole thing by 1 plus R divided by N. And then you raise that denominator to an exponent of N times T. Okay, or you can use the present value formula that is built into your spreadsheets, right? So let's do that over here. We'll start by using the formula itself. So this is how you would type this in if you were going to do this. Okay, let me try one thing. So Brooks is saying that he is not able to hear me or see me. Is anybody else having trouble hearing me or seeing the screen when I share it? No? Okay, so looks like Brooks is definitely having trouble. Okay, let me try sharing this and see if that makes a difference or not. Brooks, are you able to see the screen now, which I'm not seeing? Your camera is turned on, so I don't know if you're having internet trouble at your end, or is something else happening? Sabrina, for that matter, I'm not seeing your video either. Okay. But if the rest of you are not having trouble, so that makes me think that maybe my end is okay, but your end might be where, I don't know, Brooks, if you are able to, let me see, he may not hear me. See if he can check his modem and that would make a difference. Okay, while I hear for some response from the students, guys. Okay, Sabrina is suggesting headphones. Okay, Sarah, since you sent that message to everyone, hopefully I think Brooks should be able to read that and see if that's what he did. Yeah, unfortunately with technology, there can be like, 10 different things that happen that, didn't work with you. So yeah, I didn't even think about that. If you don't select your audio, that also does not let you hear what's going on. Okay, that should be fine. Yeah. All right, guys, while our two classmates are troubleshooting, so let's talk about this. So our formula is P equals A divided by 1 plus R over N, and then the whole thing to the NT power. So when you're typing this in, of course, our 6,000 should go to the top, and then we would be dividing that by 1 plus. Remember, as a decimal, your 6% becomes 0.06. We're dividing it by the N value. And then, of course, we would raise it to the exponent of N times T, which we were doing this for 8 years. So we would do it that way. And then, basically figure out what the dollar amount would come out to be. So when you're typing this in, remember, you will have to do 6,000 divided by, and then we will do open parentheses, 1 plus 0.06 divided by 12, close parentheses, then we would raise it to the power of 12 times 8. So that's how we're going to have to type this. And then when you put this in the cell, of course, we always put an equal to in front of the sum, what you're typing in, so that Excel or spreadsheets knows that we are trying to do a calculation here. So that would be 6,000 divided by, open parentheses, 1 plus 0.06 divided by 12, close parentheses, and then we raise it to the power of, then again, since you're doing 12 times 8, put that in parentheses again, and then 12 times 8 would come out to be our math. So you can see this comes out to be 3,717. Now, this was me typing in the numbers just to show you how to place that. And I'm just going to move this here. But remember, we normally use cell references. So in this case, I would start by clicking on, doing the equal to sign, then clicking on the cell where we have our 6,000. then the division, open parentheses, 1 plus, then this is where I would click on my 6% box. So again, another cell reference divided by where we have the 12 for the monthly. Close my parentheses, raise it to my exponent, and then again, open parentheses. This time we would click on the box with 12 again and multiply it by a number of years, which is the box for 8 years, and then close that also. So instead of typing numbers, we want to do cell references so that, if we changed any calculation, we would be able to, not have to go in and retype the formula. So this was using the formula. Again, if you just go to the cells, you will see how I typed those in. So the first one was with the cell reference. The second one was just to show you what happens if you just put numbers in there. Now we will use the built-in present value formula and see what that will give us. So in this case, again, equal to, that's where you're going to start. And then PV for the present value. Now, again, remember the first argument is going to be your rate of interest divided by your compounding period. So R divided by N. So again, I'm just clicking on the cells to do that, comma. Then you are going to do N times T. So that's going to be the cell for 12 times the 8 years. So 12 times T, that's the second argument. Then again, comma. We're not making regular payments, so you're going to put 0 for the third argument. And then for the last one, we're going to click on how much we want at the end of 8 years, and that's the 6,000. So that's how you type in your formulas. And when you hit enter, you should see you'll get the same dollar amount as we did when we just, typed in our formula in. And same thing like you saw with the future value, guys. This shows up as a negative number, but obviously we know this is not a negative answer. So that's what this would end up looking like. So this is your answer for, what was it, problem number 13 or 12, sorry. No, this was problem number 12. So this is example number 12. So questions on this one over here, guys, on how to use the present value formula or, the calculation behind it.
No question. I just want to copy down your formula for
Yeah, sure.
the PV.
Yeah, sure.
So it's 816 is the rate, and then B17 is N. Okay, that's where I was getting a little confused.
Okay.
And then comma, time divided by, nope, it's N divided by, or
Yes, so
N
you start by
times
R divided by N for the first one, then N times T for the second one,
okay,
0 for the third one, and then your future value for the last one.
and that is,
or as we call it, A.
15. Okay. Okay. Thank you.
Yeah, you're welcome. Alrighty, guys, let's do another example just to make sure everybody is comfortable working with this. So we did number 12. Let's see, do we have something else? This is talking about depositing. Maybe only number 13. Looks like it. All right, we'll do 13, I guess. So this one is talking about how much do you again need to deposit in an account now in order to have $20,000, which will of course become our future value or amount, to have $20,000 in the account in 4 years. And then let's see, the account assumes that you are earning a 5% APR, which is being compounded quarterly. All right, so this is the information we have from our problem. Let's move over here. And then let me see what dollar amount you guys come up with, and then I'll go ahead and put it into our formula here to see that if we're getting the same answer. So go ahead, do the calculation, use a spreadsheet if you want. Which is kind of our goal, is to get you guys comfortable with spreadsheets, but of course you can do this with a handheld calculator also. So once you're ready, go ahead and share your answer with me, and let's see what that number comes out to be. All right, Michael, I see your answer. That's okay. And let's see what the others are coming up with. So we need 20,000 in 4 years, and the account will be earning 5%, and it's being compounded quarterly. Okay, Sabrina, I see your answer. Sabrina, that looks to be a little bit on the smaller side, because since you only have 4 years to get to 20,000, your initial principal will have to be a little bit of a higher dollar amount. Okay. Terry, I see your answer, and let's see. That number looks good. So again, remember, you can use the built-in formula, the PV formula, or you can type in the answer like we did here in P equals A divided by 1 plus R over N, and then the denominator raised to the power of NT. So either one of these or the built-in formula PV. So whichever one you want to use. All right, what about the rest of you? So I have answers from Terry, Michael, and Sabrina. Terry, go ahead.
When we go to the PV formula, that's to make sure that our principal is correct, right? Or in future, what we need to invest.
Yeah, what you are investing today, so that in the future, like on the screen, we were talking about 6,000 before, and then we'll be modifying this with the new example of the 20,000.
Yeah, I got that part correct, but then when we go to the PV formula, I'm a little confused. Do we, because we use that.
Go ahead.
Okay, I'm just, because it says equals PV and then parentheses. And so does that mean A, our future value, is our principal value?
You are finding the present value, the principal, based on how much you need in the future. So it's basically literally the reverse of your future value formula, because in the future value, we put what money we're depositing today, so that in the future we'll have whatever that answer comes out to be. In the PV formula, what we are saying is we want, $6,000 or $20,000 in the future. So how much should we start with today? How much should we deposit today? That's what you're finding.
Right. And then when I'm adding the cells in and I have PV, what am I clicking on? Am I clicking on the, in your example right here, 3,717?
No,
Because it says PV.
yeah, so where you have equal to PV, then in the parentheses, you start typing in, because remember with the PV formula, the first argument is R divided by N. So I clicked on this cell and then I divided it by this cell.
I think I know what I did was I put in, so I just put PV in, and still that didn't work. Okay.
Did you
Yes.
have the
Okay. It worked.
Oh,
Yeah.
it worked?
I put in a different cell. That was what I was doing. I put in, I think it was the future value. I think that's what I ended up putting in by accident was, and that's why my
37.
formula in the cell didn't work. Yeah.
Okay.
Thank you.
Yeah, no worries. All right, guys, so let's take a look at how we can get the answer for this. So where's my cursor? There we go. All righty. So now what we're going to do is, of course, we need a future value of $20,000. So I'm going to change this to 20,000. And you will see as I keep changing each of my cells, these answers are going to keep changing because I used cell reference. Now this one here is not going to change because I actually typed in numbers instead of using cell reference. So, of course, this box here will be different from these two because these guys are using cell references. So these ones will keep changing as I keep, changing my values in these 4 boxes at the top. So let's see what that comes out to be. So we're needing $20,000 in 4 years time. So this will now, the T value will become 4 years. So again, you'll see how my number at the bottom changed. Our interest rate is only 5%. So 5% as a decimal, of course, comes out to be 0.05. And then we're doing this quarterly. So of course, our quarterly is going to be 4 times a year, and you will see what that balance changes. So again, I was using cell references here, and you can see I had clicked on each of my cells to do this math. That's why this number changed. Same thing with the PV formula. I had clicked on the cells instead of typing the numbers. But on this cell over here, since I had actually typed in the numbers, these values did not change when I changed my 4 cells at the top. And that's what happened. So that's why using cell reference makes a lot of sense, because then you don't have to keep retyping the formula in. So I'm just going to go ahead and erase this guy. And now here you can see we will need, and as I was saying, because you only have 4 years worth of time, your principal is going to be fairly high if we're going to end up with $20,000 at the end of that 4 years. So this is going to be our principal amount over here. And this was, of course, example number 13 that we were looking at. Okay, so Sabrina, I would just make sure that you are able to come up with this number once you use the amount from, from this particular example number 13, just to make sure you do come up with that. Okay, no worries. All righty, guys. So let's go ahead and move on to our next example here. And we are now actually going back, and I had talked about this very briefly the other day, but we are now getting into how to do continuous compounding. So when we're talking about continuous compounding, basically we are talking about a little bit faster than if you were compounding daily, right? If you were doing it almost like every minute or every second, that continuously your interest is being calculated. So it just gives you a little bit more of, a balance in your account if you're going to be compounding continuously. So here, your formula is significantly different because you will see it's A equals P times ERT, or the best way to remember is just remember this as the PERT formula, because obviously that's kind of what it spells out, but it is P multiplied by E. So it's P multiplied by E, and it's only the E that gets the exponent of the RT. Okay, so the P does not have that exponent, it's only on that E. And this E is your natural number E, or as they're calling it, the irrational number E, which is approximately equal to 2.71, 828, 1828, and it keeps going from there. So you can usually find the natural number E on your calculator. If you look for the natural log key, the ln key, usually on top of that is where you will find like e to the x, or sometimes they may have e raised to a exponent. So this is what it would look like on a calculator. In Excel, you actually have a built-in function for the natural number e, excuse me, and it's called exp. So you can kind of see how they are showing you if you were working with this in Excel or a spreadsheet. This is what that formula would end up looking like. So, again, A stands for your future value, how much money we want in the future. P, of course, is your principal or present value. Your R is going to be the rate of interest. And then T, of course, is number of years. So you will notice there is no N here, right? Because there's no compounding period. Since you are compounding this continuously, you're not going to have an N value in this case. So the way this formula works, let's take a look at this example here. So they're telling us we deposit $4,000 in an account that earns an interest rate of 2.75%. And you will see they specifically will tell you that it's compounded continuously. And when they tell you it's compounded continuously, we know this is the formula that we are using. How much will you have after 7 years? So of course you can see we are depositing 4,000, that's our principal. Our rate of interest is 2.75. It's being done continuously, so no N value. And then your T is 7 years. They want to know how much interest will we earn and what percentage of the balance will the interest be. So if you were just going to put this into the formula, then as you can see, you just take your 4,000 multiplied by the natural number E, and then E gets the exponent of R times T. So that's my rate of interest of 0.0275. And then we're doing this for 7 years. And you will see your balance comes out to be $4,849.11. If you were going to put this into a spreadsheet, this would come out to be 4,000 multiplied by your natural number E, which again is the EXP function. And then for the EXP, since E is where the exponent happens, inside the EXP, you put the R times T value, so the 0.0275 multiplied by 7, and of course you will see we still get the same balance, $4,849.11. So this is going to be your future value. Now they're asking us how much interest did we earn. So remember, for the interest, you just do A minus P. So obviously, oh, it's down here. Let's get rid of some of this writing here. Okay, so we know we earned an interest, a future value of $4,849.11. Subtract that from the original amount that we started out with, 4,000. So of course, we earned an interest of $849.11. And then to find the percentage based on the balance, of course, you take your interest rate divided by the future value you had, and then you get your percentage. So our interest is 17.5% of our future value. And of course, we did similar calculations like this with other examples last time. So that percentage part is kind of similarly based, and then you can kind of see what that value comes out to be. So after 7 years, you will have earned 17.5% of your account as, your account balance as your interest. So that's your continuous compounding formula. So let's do our own example based on that. Quarterly, daily, this is monthly, annually. There we go. Okay, let's actually do number 20. I kind of like that because they're doing a comparison and we can do something else just for practice later on. So they're telling us you are depositing $10,000 into an account that earns 5.5% APR compounded continuously. Your friend deposits same amount, $10,000 in an account that is earning 5.5% APR also, but this one is compounded annually. So we are putting it into a compounded continuously account. The friend is doing it in a compounded annually. So how much will you have in your account in 10 years? How much interest did you earn in 10 years? Of course, we need to do this for both. Both of the people who are depositing money. Okay, you know what? Give me a quick second here. Okay, too many things open, so I'm having a hard time seeing what I have open and what I don't. Alrighty, let's go over here and let's see what we have. So $10,000 for both, 5.5 interest for both, and one is continuous, the other is compounded annually. Okay, so let's do that over here on the side. Okay, so we have principal. Let's see, rate of interest. We have time. We have N. Okay, that about sums it. So we are doing so this is us, this will be the friend. So both people are depositing $10,000 into their accounts. I'm going to set both of them as a currency. Then for our rate of interest, I'm going to set both of them as a percentage. So before typing my number in, I'm actually going to format it as a cell. And then both of us and the friend are earning a interest of 5.5%. So we can see that. Now, here's where it's going to be different. Now, they're telling us, time frame, of course, needs to be 10 years for both, because you can see in parts A and B, they're telling us how much will we have earned and how much will our account have in 10 years. So the time is going to be 10 years for both of them. So this is time in years. And then for us, this was compounded continuously. So of course, we're not going to have any value in there. And for the friend, they told us it was compounded annually. So that means their compounding period is going to be 1. So this guy was annually. So in our example, for us, we are going to have to use A equals P times E. And I guess I'm going to type it in like this. And then E is raised to the power of R times T. So that's going to be for the continuous compounding. Now for the friend who is getting compounded annually, of course, we have to use the regular compound interest formula, right? So that one, remember, was the formula of A equals P, and then in parentheses, and you know what, this should be P times parentheses 1 plus R divided by N, and then remember you raise it to N times T. So that would be for our friend. So let's take a look at how we can do our calculation, which is compounded continuously. So this is where we start again by equal to. Then you click on just the principal, the $10,000 for us. And then we multiply this. Make sure you use the multiplication symbol. And this is where you're using the built-in function EXP, guys. So this is going to be your EXP. So we're going to click on that. And then we raise it to an exponent of rate. So R times T, which is of course 10 years in our case. So again, you will see I'm doing cell references here so we don't have to keep typing the formula again. So this is what you will end up getting. So by the end, we get to 10 years, our 10,000 at 5.5% compounded continuously will get us to 17,332.53. Now, remember for this continuous compounding, guys, we do not have a built-in formula like PV or FV, right? That's only for compounding interest when it's compounded, monthly, yearly, any of those compounding periods. So for continuous compounding, this is the only way you can do it. So take your principal, multiply it by EXP, and then for the parentheses of EXP, you're going to put your R times T value in. Now, for the compounded annually for our friend, again, if you're using the formula, you can do equal to. His principal was also $10,000. Make sure you have a multiplication symbol after that. Open parentheses, 1 plus, again, your rate. But this time we have a compounding period. It's compounded annually. So compounded annually one time. So divide by 1, close parentheses. And then we're going to raise this, open parentheses again. And then it's N times T. So 1 times 10 years. So I'm going to click on my cells again. And as expected, this balance will come down to be lower than what you did with continuous compounding, because, with your friend's account, only once a year is where the interest is being calculated, right? But when we say continuously, like I said, you kind of think about it's working even faster than every second if you were earning, interest on your account. Now, for your friend, remember, you can also use the future value formula. So if you did the future, not that one. If you did the future value formula, then this one would be, of course, R divided by N. So I'm just clicking on those two cells. So start by R divided by N, comma. Then it's going to be N times T for the next argument, comma. We're not making regular payments, so I'm going to put 0 for the third argument. And then for the last one, of course, how much money do we deposit? $10,000. Close your account, and you will, of course, see both these numbers should come out to be the same. So either type the formula in like I did by, clicking on my cells, or just use the built-in future value formula. So this guy came from the future value formula. So remember, as I was telling you earlier, only when you have a compounding period, and it can be, annually, semi-annually, quarterly, monthly, weekly, daily, doesn't matter. It's only for that you can use the future value. When it's continuously, there is no built-in function that we have to use. So you can only use, for continuously, you can only use, this formula here, or the way I typed it into that cell. So just a little bit of a difference on depending on what information you are given and what you are able to use. Yeah, Terry, go ahead.
Can you show us again what was the formula in the cell for
this one?
Yeah.
Yeah.
So if you just put in exponent.
So it's exponent, but it's specifically to that natural number E. This will not work with other exponents.
Okay, so I'm confused on how you find the EXP, because there's no E to put to the R and T power.
So that's the built-in formula. So if you just do equal to EXP, you will see that it shows up as Euler's number, which is the natural number E, which is approximately 2.718. So if you take this formula and raise it to the first power, it shows you what it's equal to. So this is the value of EXP. This is what that natural number E stands for. And you
okay, so the EXP is the E times, in parentheses, R times T.
Yeah, this is your E. Yeah.
Okay, that's my E,
Excel
but I still need to do the R times T.
Yeah, and then in the parentheses, you do the R times T. So let me go back up to this cell here. So you will see in the parentheses, I have the F16 times F17, which was our R and T values.
Okay, yeah, totally got that part. It's just there was no square that said EXP on it. So that, or the E. So can we put a cell in that has just the E?
So if you wanted to do it like that, then let's clear this out for a second. So let's say if you were going to put EXP, I would probably put it here, which technically is not N, but you could do E, and then you could do EXP raised to the first power.
Raised to the first power.
Yeah.
Okay, EXP, the first power. And when you say raised to the first power, can you
I just
one
put
more time
that
click
one in
on
the
that?
parentheses, yeah.
It's just one in parentheses. There's no caret or anything like that in there. Okay.
No, yeah, not for the EXP function, yeah. And then for using it in your calculation, then you would do, you know, of course, the P to the 10,000 multiply by the EXP. But then for this guy, I would imagine you probably have to raise it because you're not using the built-in function anymore, right? You're clicking on the cell. So then you would have to do F19 and then raise it. And then in parentheses, you would do your R times the T. So then your math would look a little bit different.
Sorry, the dogs are barking, so I was muting myself. So I just need to write that down.
Yeah, go ahead. So it really just comes down to, you know, how you're treating that natural number E, right? So if you're giving it its own cell, then like you can see in the line that I have clicked on right now, I do have to use the caret symbol. However, if you were using the built-in EXP function like we did in this first cell here, you will see, guys, I didn't have to use the caret symbol to raise it to an exponent because EXP is built in. So we know whatever you're putting in the parentheses is already being raised to the exponent. But if you did like how Terry was saying, and I'm just going to put a gap in here. Hold on a second. Again, like I said, I have too many things open, so I'm having a little hard time seeing my screen. So if you did a specific cell for the E value, then, you know, of course, you would have to use the caret symbol to raise it to the R times T. But obviously, as you can see, our dollar amount is going to come out to be the same. So it's just how you're typing in your formula that will make a difference, Terry, but either one of them is going to work mathematically.
Okay, it's just coming at me really fast. I'm trying to, you know, compartmentalize how I'm going to put this into the cell.
Yeah, so again, I will leave this on here so you can kind of play around with both ways and then see which one to you makes more sense or would be easy for you to translate, and then go with that method.
Okay.
Okay, so this was, what was this example number, 20? So this was for problem number 20. Okay, guys, just for practice, let's take a look at one more example about continuous compounding. Let's see, what is this guy talking about? This is talking about percent balance, quarterly, daily. Yeah, let's look at number 18. So they're telling us we are depositing $1,000. So that, of course, is our principal. So we've got $1,000 into an account earning 5.75% APR, which is again compounded continuously. And then they are telling us how much are we going to have in our account in 15 years. Of course, that's your time. How much total interest will you earn? So we need to know basically the interest, we need to know the balance, and what percent of the balance is the interest. So these are the three things they are asking us to find. Okay, so this is number 18. Let's translate this over to our spreadsheet over here. Okay, so again, I'm actually going to leave this as it is from our previous example, and we can just start over on a new set. So principal is 1,000 and convert that to a dollar amount. Our rate of interest, so I'm actually going to pre-format this again. Click on my percentage and then I'll type in my 5.75. This is compounded continuously, and then the time, again, remember this is in years, is going to be 15. So again, Terry, like you were saying, if you wanted to use your E separately, then for your E, you can go ahead and do equal to EXP and then raise it to the first power. So again, if you wanted to use the built-in function, remember guys, this would be P times E. And then E has to be raised to the powers of R times T. If you're going to be using the EXP function, so that would be P times, and you would do the EXP. And in this case, you just do R times T. You don't have to use the caret symbol. So just to show you how both of those will work. So again, for the first one, we are going to do our principal as 1,000. Multiply by your E value and then raise it to the RT. And actually, you know what? I'm going to wait to see what answers you guys come up with before I share the answer. So go ahead, do the math. And let's see what A value you are coming up with. And, you know, once we know the A value, then we can easily calculate what our interest is going to be. So let's just make sure you guys are able to come up with this. And I'll go ahead and do this on my calculator so I can verify your answers. So 1,000. Okay, there we go. So what will your 15, after 15 years, what will your $1,000 grow to? At 5.75% compounded continuously. Okay, Sabrina, no problem. Okay, Michael. That looks good, very nice. Now, you know, we're starting out with a pretty small dollar amount, so don't expect it to grow, you know, into like a six-figure value, because you're honestly just starting out with $1,000, right? I mean, you're going to see a good amount of growth, but not something where it's going to go into, you know, huge chunks of money. Now, if you had started at 10,000, yes, we would have seen a big increase, but at 1,000, it will be a decent increase, but nothing. Okay, so I've got an answer from Michael. Anybody else come up with a number? And we just have a last part that we need to talk about in this. So let's get this example done so we can do the last part of 2.2 and get this section completed. Terry, are you still having trouble coming up with an answer? Yeah. Are you trying to use EXP or are you trying to do EXP separately and then use it in the formula?
I'm looking at the formula that you have right there, which is P times E, with the little caret and the R times T in parentheses. I put in, if I put in my exponent, which is that E cell that I created,
Mhm.
I'm not getting an answer. I'm getting a huge answer.
Okay, let's check that. So
So,
you did 1000 or the p-value and then
right,
multiply it by this cell, right? Where you had the E.
yes,
Okay, and then you raise it and make sure this is in parentheses,
yes.
the R times the
Uh-huh.
T, and then close parentheses. And this is what you should come up with.
Okay, let me look at yours one more time because my number again is huge. Okay, what do I have there? Yes, that's what I've got.
Now, do you
But I
have
don't
the
understand.
multiplication between your first cell for the p-value and the e-value?
Yes,
Okay. And then when you did the caret, and then in parentheses, when you're doing R times T, did you put multiplication there?
no, the caret is where the caret is supposed to be. Then in parentheses, there's a multiplication.
Yeah, in the parentheses.
Mine looks exactly like yours, unless I'm putting my numbers in the wrong order. But
What was your rate of
principal
interest?
times my rate of interest is 5.75.
Okay.
Oh, maybe it didn't go to percentage. Maybe that's my problem.
Yeah, because normally
Okay,
if
let's do that
your
again.
answer is coming too large, sometimes it can miscalculate the R value.
Okay, just a second. For some reason, let's go back here. That's probably what the issue is.
Okay.
Delete it. 5.75, correct? Okay, and then these look right. Okay. Sorry, everyone. Times.
Okay, guys, so
Okay,
while
times
Terry
the
is still
rate.
trying to figure that out, let me just show you if you were using the built-in EXP function. That one, the only difference is you don't use the caret symbol. So you would click on your 1000 where the principal is, multiply, and then this is where we use the EXP built-in account. No caret necessary, just do the EXP, and then in the parentheses, we would do our rate of interest, 5.75, multiplied by the 15 years, close parentheses, and of course, you should expect to see the same answer. So just to again show you two different ways of doing this, but you should get the same dollar amount. So it would just depend on, do you do the EXP separately to the first power like we did over here? Or do you just use the EXP in the main formula itself? So, just keep this example handy as you guys are looking through, these examples over here, just so you can, like I said, find out what method works the best for you. And this was, of course, number 18. So let's go ahead and put that here. So this was example number 18. Terry, how are you looking?
I got it. And that was, it was my decimal point.
Your
I mean, it
decimal.
was my rate of interest. I thought I had formulated correctly and it wasn't.
Yeah, and actually Sabrina and I ran into that problem last time. We were looking at one of her examples. So what she decided to do was actually just leave it as a decimal answer. So she didn't even bother with the formatting, and instead of putting 5.75%, she decided this was safer for her to use. So that's what she has been doing, and it helped her. So if you think that would avoid confusion, you are obviously welcome to go ahead and do that.
Thank you. I know how to totally do that, and I thought I had it formulated correctly, and that's why it was so confusing. Because I thought I had everything in the right
You
spot.
had everything exactly. Yeah.
Yeah. Okay.
And that's kind of one of those things when you are using built-in calculators and stuff like that, you have to make sure the information entered is correct, because even one change in decimal place, the final answer goes completely different. Alrighty, folks, so this was finding our future value. Now, of course, they also want us to find the interest and what percentage the interest, oh, sorry, not that. So let's remove this here quickly. So to find our interest, obviously, you will take your future value, so take your A, and from that subtract your principal. So of course, if you're subtracting $1,000, you should end up with $1,369.08. So that will become your interest. Now, the last part they were asking us is what percentage of the balance is the interest. So remember, this is where you take your interest and divide it by your balance, and this will of course come out to be a percentage value. So literally just click on the cell where you have the I, divided by your future value. And since you're doing basic division, this will come out to be a decimal number. Okay, Amanda, perfect. I'm glad that it worked for you also. So you will get a decimal answer. And then this one, remember I told you, just click on that format as a percent icon here, and this will automatically convert it to a percentage for you. So our balance of $1,369.08 is going to end up being 57.79% of our balance that you ended up with, the $2,369.08. I mean, that's a huge growth. So as I was telling you earlier, because these numbers are in thousands and 2,000, it may seem like our money didn't grow that much, but look at in percentage, you had more than half of your money grow. I mean, you literally have 57.79%, which came from the interest you earned over these 5 years. Had that been 10,000 instead of 1,000, and let me just show you what happens if we change that to 10,000. Look at the significance difference between our amount and our interest, and just how much that money has grown. So it really, sorry, I did 100,000 instead of 10,000, but same thing, even with 10,000, you would see a huge growth. So it was just because we started out with, a nice meager amount of 1,000, but we still had really good growth in our balance over here. Alrighty, guys, so this was number 18. Let's save this, let's clear this out. And then the last one I wanted to talk to you about, and we did a little bit of this talking last class. This is, what if your interest rate is given to you in 2 different compounding periods, right? Either compounded continuously or compounded, well, continuously would be kind of difficult to assess, but if it was given to you compounded daily or compounded monthly, quarterly, semi-annually, which account is giving you a better investment? If we wanted to find out, the idea is we take our interest rate and basically try to see if we broke it down into simple interest, which one would give us a better earning. So you do have a built-in formula in your spreadsheet, which is called the effect function for the effective rate. And then basically you start by putting in the stated rate you are given. So, if they tell you it's 5.75 compounded monthly, then that's going to be your compounding period. So put your rate of interest, put your compounding period, how many times your interest is being calculated, and this formula will give you, in simple interest terms, which one is earning a higher interest. So let's take a look at this example over here. This one is telling us that you are comparing an account that pays, and I'll keep this effective one visible. So we're comparing an account that pays 5.25 APR, which is compounded monthly. And we're comparing it with an account that pays 5% APR, but this guy is compounded daily. So we want to know which of the 2 accounts will give us a better interest rate, if we convert this to a simple interest value. So you will see for the 5.25% compounded monthly, your formula is, again, you put the decimal answer for 0.0525, compounded monthly, of course, tells you n equals 12. So you've got the 12 in there. And this actually comes out to be 5.38% or 0.0538. So this is what you would earn in a year if you convert this to a simple interest. So what if we were to compare this with the 5%, which is compounded daily? And if it is compounded daily, then of course your n is 365. So now 5% would become 0.05, 365 for the second argument in the effect formula. And you can see this guy comes out to be 5.13%. So even though you have a higher compounding period, because this is daily compared to monthly, but because you did start out with a slightly higher interest rate with the compounded monthly of 5.25, that one actually keeps its higher status. And you can see at 5.38 compared to 5.13, you know, this guy, of course, is going to be a better rate that we would want to invest at. And so, of course, in this case, you know, we would, if this was a savings account or something, we want to go with the 5.38%. They kind of do the same thing over here in this example. So this time we are comparing 6% compounded quarterly, and then 5.95%, which is compounded daily. So interest rates are pretty close to each other. So let's see what happens with the quarterly and daily. So 6% compounded quarterly. Quarterly is, of course, 4 times a year. Put that into your effect formula, and you can see in simple interest terms, this guy comes out to be 6.14%, right? 5.975 compounded daily. Daily, of course, again, is 365. Put that into your effect formula, and you can see this guy comes out to be 6.16. So our interest rates were pretty close to each other. Of course, the 5.975 was just a hair smaller, but because he was compounded daily, that gave it a slight edge, and this guy ended up becoming a little better investment, right? Just because you were getting, you know, even though it's in the hundreds, 200ths of an interest rate higher. So, I mean, you know, obviously anybody would want to go with the higher interest rate, right? So that's basically how that effective rate works out. You're just converting whatever your compounding periods is and taking that interest rate and breaking down in terms of just simple interest, because then it makes it easier to compare. Because, you know, sometimes compounding quarterly is better than compounding, you know, daily, depending on what interest rate you started out with. So they actually have, what was that example we were working on last time? I think it was the Braylon and the Angad formula that we were looking at. All right, Kendall, we're just going to wrap up this example and then we're done with section 2.2. So we were working on this Braylon and Angad example, and we hadn't done part C because this one was telling us Braylon is investing at 4.6% compounded quarterly, and Angad was investing at 4.55%, and he was getting compounded weekly. So what would their effective rate for each account come out to be? So let's take a look at their math over here. So we'll go back, and this was your example 14 that we were looking at. So let's talk about their effective rate, and they had us do this at 30 years and 15 years. So now we are looking at part C for this guy. All right, so this will be for Braylon, and this will be for Angad. And then remember, you are using the effect formula. Oh, 2 F's. So effect formula, and then for Braylon, we had 4.6%, so that becomes your first argument. And then compounded quarterly, so that becomes the second. And again, you will see, guys, I'm just using the cell reference to figure this out. So this comes out to be, as you can see, 0.0467. You want to convert that to a percent. So in simple interest terms, Braylon is actually getting 4.68% interest in terms of simple interest every year. Now let's see what Angad is doing. He had 4.55 as his interest rate, and this was being compounded weekly. And you can see he is getting 0.0465. If I convert this into a percent, you can see even though he was compounding weekly, which is much faster than quarterly, but because Angad started at 4.55 and Braylon was at 4.6, he still keeps a higher interest rate. So he's definitely making a better investment. And we knew that because look at their future value over here. Braylon had 2383.06, whereas Angad had 2373.87. So of course, Braylon had a higher interest rate, right? Future value. Even after 30 years, Braylon was at 4732 and some change, but Angad was only at 4696. So again, after 30 years, obviously, Braylon was still making more money. So that clearly tells you that, Braylon was earning a better interest rate. And we have just proven that by looking at their interest rate in terms of simple interest. He's at 4.68%, and Angad is just shy at 4.65, but you can see there's, a slight difference in their balances over here. So it's really interesting, guys, how your compounding period and interest rate can make a difference in what you are earning. So just because you have more compounding period does not automatically make it a better investment, because you do have to look at what interest rate also did you initially start out with. But it's amazing that, we have something like this effective formula, the effective rate that can tell us, who has a better investment, or which, if you're shopping at different banks or financial institutions, you can find out which account is going to give you a better or a higher interest. So questions on this one here, guys? On the effective rate? Okay, so we are officially and finally done with section 2.2. As you will see, this is the last one, and then we just go into examples from that. So on Wednesday, we need to start working on section 2.3, and then we still have section 2.4. So we need to talk about savings accounts, and we need to talk about loan payments. So those are going to be our last two sections we need to do in both of these chapter 2 before we can take our exam. So I honestly am not sure if one class will be enough to finish this. If we can, we will try to. If not, we'll obviously give you guys enough time to practice and everything. So I will go ahead and open up both 2.3 and 2.4 homework, and tentatively, I will put a deadline for Friday, but don't think of that as set in stone. We'll see what our progress looks like. I don't want you to rush through homework or, feel any of that pressure. But just to put a date, I will put it for Friday. And then, like I said, let's see how things go on Wednesday, and we can always change those due dates. Okay, so don't please worry too much about those due dates for now. I want to give you guys enough time to practice, but we do have to finish section 2.3 and 2.4 before we can take the exam. Okay. All right, guys, if you have any questions, I'll be happy to answer them. And if not, have a wonderful afternoon, guys, and I will see you on Wednesday morning. So be careful, everyone. Take care, and see you on Wednesday.